Hello, this is Naireza Alvin, and I'm working with Mayanja Janet on reinforced deep Q knowledge distillation credit risk prediction model. Um, Traditional credit risk prediction models that use uh, linear regression and other basic algorithms. They have a low capability to capture complex patterns in the borrower behavior, most especially when data is highly dimensional. So I decided to come up with a way of combining different algorithms to be able to capture complex patterns in high dimensional data so that the credit risk prediction model can be more accurate. We're going to use deep Q learning, knowledge distillation, reinforcement learning. Um, the issue is to make this model more and more um, easier and more accurate. Um, we are going to do that in a way that we have reinforcement learning, deep Q learning, knowledge distillation, where we aim at compressing the model so that it becomes more small and more efficient at the same time while maintaining its functionality and efficiency. So these are the key terms. These are the key terms. Um, Credit risk prediction. Here we are trying to assess the likelihood of someone who has borrowed a loan. How likely are they to, default or pay back? That is what we are trying to assess here. In reinforcement learning here, this is where you have an agent. An agent is operating in an environment and then it's learning from the rewards or the feedback that it's getting from the environment based on its actions. That's how it keeps on learning and getting better. Deep Q learning here, this is call it a reinforcement learning method, but it combines Q learning and deep neural networks. It approximates the Q value function. The Q value function, it estimates the expected cumulative reward for each state action pair. You have state action pairs, you pass them to the function estimates how good the state is. Yes, it estimates how good the pair is for each state action pair. So the experiences of the agent are stored in a buffer, and these experiences are used to update the neural network's weights, and they keep on improving the prediction of the model. This is how the knowledge, this is how the teacher model in knowledge distillation is going to learn. Then knowledge distillation is why I'm talking about the teacher model. We have two models, the teacher, which is more complex, and the student, which is mimicking the behavior of the teacher. The student is believed to be making better predictions, and it is learning from the teacher. Deep Q learning, this is the state action pair, it's the Q function, and this is the Q value that is predicted by the Q function basing on the state action pair that have been passed on to it. Knowledge distillation, we have the teacher model, it is more complex. We have the student, it is simpler. Knowledge, predictions from the teacher are passed on to the student here. And then the student is believed to make better predictions. In this particular model, how we are going to combine them to all these algorithms to form a more accurate model. When the student, after it makes better predictions, it passes them back to the teacher. That is more of a reward. so that the teacher learns and gets better through reinforcement learning. Thank you. I'll let my colleague to take you.
Hello, my name is Mary Janet, and I'll take you through the rest of the project ideas. And so this is a problem statement and some of the application domain specific problems that we have. Like this is the really problem that we wanted to solve. We wanted just to get a more accurate credit risk prediction system or model, and such that we can replace it with the traditional models that are there right now, because they're facing a problem. They have like limited ability to capture complex patterns in like data that is high dimensional, that is huge data. So we want to improve on the accuracy through using knowledge distillation and deep Q learning and the reinforcement learning, such that the model is going to be kind of like smaller, but it's going to be more efficient, and it's going to like be able to work in those environments that have resource constraints like small devices. So the technical computational problems that we have is like there's the machine learning algorithm or model we face when it's learning. The data is too high dimensional, but now we have no distillation to cover that gap. If our data set is like imbalanced, the model could get some bias and catastrophic forgetting. Like since we are going to use some neural networks in there, the model could start like forgetting, but we have to find a way to cover like that gap of forgetting, knowledge loss, such that the model doesn't lose, maybe like through deep Q learning and um, like uh, reinforcement learning through like the rewards, continuous rewards. And our suggested solution was, how about we create a model, merge these things together such that we can cover the base of accuracy, that high dimensional data that financial institutions may have, because they may have so many customers, and probably like a model that is better, like using knowledge distillation. If you have like a teacher and student model that is learning, the student model learning from the teacher, and the teacher getting rewards from the student model. I don't think that's in place right now, but I think the models would learn better with that kind of method, merging those three methods of machine learning. Our data says this is the resource to our data set. It has 12 features, 150 rows, and these are some of the pre-processing steps that kind of went through, handling missing values, imputation and dropping. But I think for us, in case we decided to drop, we may do some feature engineering, create some new features that will help us predict better, and maybe some scaling through normalizing the data. These are some of the references. We check out like that survey for people who are trying to deal with knowledge distillation to very helpful. Thank you.